So using what I could find around the house, because I don't have a turntable and 3 blocks labeled A, B, and C, we're going to use a bike wheel. So like this, we can look at the reflector is white, blue piece of tape, and the red piece of tape. And take a screenshot of this and talk about it in a moment. All right, so what I did on here was, if you look carefully, you will see a red line here that represents the radius of a blue line here, which represents the radius of B, um, with a blue tag, and a white line here, which represents the reflector or the radius of block C. Going back to the video for a second, we saw the radius in the prior screen. Now we're watching this in slow motion, and you can see they all cover the same number of, they all travel in a circle at the same amount of time. So that would be the same 360 degrees or 2 pi radians in whatever time it took to travel that circle, which means they would all have the same angular speed. Now to address the linear speeds. So we're back on the screen with the 3 radii. In the next shot you will see I will have drawn 3 circles representing the distance in which the reflector travels, a linear value. The blue piece of tape travels, also a linear, or what's referred to as a translational value. And then again, what the red piece of tape travels in one circle. Okay, well, I realize when you're looking at this picture, these circles aren't perfect. You can talk to my production manager about it, but this will get the point across. So, if you look at this for the same one rotation that they all make in the same amount of time, the reflector in white makes the largest circle, which means it travels the largest linear distance or translational distance or circumference as we typically refer to it. So the reflector would have the largest translational speed. Then you look at the blue, which has a smaller circumference, travels smaller translational distance, and therefore it would have the second largest um, translational speed. And then the one with the slowest translational speed, or the one that doesn't move as fast, would be the red piece of tape. So you need to consider whether you're dealing with a linear value, a translational value, or an angular value or rotational value. When you look at an angular value, you look at the number of angles that it travels per given amount of time. When you look at a translational value, you look at how far it actually travels, or the linear distance it travels in that period of time.